Alright, so today is October 15th. This is Ms. Figueroa, and we are doing graphing quadratic functions today. So, graphing quadratic functions, which we kind of skipped over the last time because we were more focused on the transformations that were happening and not the actual graph. So now we're going to be focused on the graph itself. So the blank of the parabola is the lowest or the highest point, and that is called the vertex. And the blank form of a quadratic function is ax minus h squared plus k. So we saw that last time, that is vertex form. So vertex form of a quadratic function gives us all of our transformations right in the form. And the coordinates of the vertex are hk. So it's just the vertex. I think every blank is vertex. So then the next one is not vertex, it's the axis of symmetry. It's the line that goes straight through the vertex that cuts the parabola in half. And so remember that the x coordinate of the vertex is the axis of symmetry. And this should say for every on both. So for every y-intercept, the x coordinate is 0. So we would have like 0, y. And then for every x-intercept, the y-coordinate is 0. So we would have x, 0. So just remember that when we're finding the intercepts themselves, that we are replacing one of our variables with 0 and then solving. Alright, so I did make a tiny edit just now to the first example because it was going to give us complex roots and we don't want to deal with that right now. So I changed the problem to be x plus 3 all squared minus 1. So the vertex is hk, so opposite of the inside, and then the end as it is. So we're going to graph our vertex, and it is -3, -1. My a value is 1, which is greater than, well, my a value is a whole number. So since a equals 1, that means I'm a happy parabola and I'm opening up. So my vertex is my minimum. And then for the axis of symmetry, remember it says that the x coordinate is the vertex. The x coordinate of the vertex is the axis of symmetry. So x equals -3 is the line that goes straight through the vertex and cuts my parabola in half. And then for my y-intercept, I'm going to plug in a 0 for x. So y equals 0 plus 3 squared minus 1. Y equals 3 squared minus 1. 9 minus 1, which is 8. So my y-intercept is 0, 8. So I'll go over here to 0 and up to 8. And then my x-intercepts, I'm going to replace y with a 0. So 0 equals x plus 3 squared minus 1. And then I'm going to solve. So I'll add 1 to both sides. I get 1 equals x plus 3 squared. Take the square root of both sides. And 1 equals x plus 3. But remember when we take the square root, we say plus or minus 1. So we have -1 equals x plus 3, and +1 equals x plus 3. So -3 on both sides, -4 equals x, -3 on both sides, -2 equals x. So on our parabolas, we should end up with, unless we're not crossing the x-axis at all, or we're hitting it at the vertex, we should end up with two different x-intercepts. So we have -4, 0, and -2, 0. So graphing now, we've got -2, 0, -4, 0, and then on this right side we go up to 8. Remember that line makes it symmetrical on both sides. So if we are 3 away, up here at 8, we're going to be 3 away. So then we can connect that left side. So just real quick, you can cross once, never, or twice. So twice, we hit right here and right here. Never, we never hit the x-axis. And then just once, we hit right on the vertex. So on our example, on number 1, we hit twice, so that's why we ended up with -4, 0 and -2, 0 as our x-intercepts. So when we're graphing in standard form, the standard form is when we have ax squared plus bx plus c, where a cannot equal 0. And a, b, and c are all just numbers. So to find the vertex in standard form does have its own formula. This is why I tend to prefer vertex form over standard form. So to find the vertex, we've got h or x equals -b over 2a. So then the axis of symmetry is x equals -b over 2a, and then k equals plugging in that value. This looks really funky, but just plug it back in. So on the second example, we're given 2x squared minus 4x plus 5. This is in standard form. So in order to find my vertex, I have to find my axis of symmetry first. So a equals 2, b equals -4, and c equals 5. So then I'm going to go x equals -b, so negative of -4, positive 4, over 2a, 2 times 2, so 4 over 4, x equals 1. So my axis of symmetry is at the line x equals 1, and then in order to find my vertex, I'm just going to plug that x back into the original function. So y would equal 2 times 1 squared minus 4 times 1 plus 5. 2 times 1 squared is 2, minus 4 times 1, which is 4, plus 5. 2 minus 4 plus 5. We've got 5 minus 4, which is 1, plus 2, which is 3. So our y value is 3, which makes our vertex, 1, which we found from the axis of symmetry, and then 3, which we found from plugging that back in. So my vertex occurs at 1, 3, and my axis of symmetry runs through that point. And then for my y-intercept, I'm going to plug in a 0 where I see x. So 2 times 0 squared minus 4 times 0 plus 5. Those both equal 0, so y equals 5. So my y-intercept is 0, 5. So on this graph, I'm going to 0 and 5. Then for the x-intercepts, I'm going to solve this. So 0 equals 2x squared minus 4x plus 5. That does not look fun to solve. We're going to do our best. we got negative 5 equals 2x squared minus 4x. I'll take out an x. I get 2x minus 4 equals negative 5. So when you get to this point where you're like, I don't really want to solve this because I know we're all going to get to that point. I know that this is my vertex. I know that this opens up because 2 is a positive number. And I know that my y-intercept is 0, 5. This is my axis of symmetry cutting it in half. So on the other side of that line, I have 2 up to 5. If this is my lowest y, and I'm facing up, then isn't there no way that I will cross the x-axis? So there's no point in solving this. Once you're able to rationalize in your head what's going on, the main thing you need to be able to do that is up or down, and then finding your vertex. So I found my vertex and it's located way above the x-axis. So there's no way that this will cross unless it were negative. Since it's a positive, it's going to go above it, and so I'm not going to find my x-intercepts because they just don't exist. So just kind of try to rationalize in your head and try to visualize what's going on your graph and think, is this up or down? Do I have my vertex? Does my vertex cross over the x-axis? And all of those questions put together tell you where your x-intercepts are going to be if you have them. So then for this last part, it's using the graphing calculator. I will leave this for you guys to do if you have the calculator. And if you don't, that is okay. I'm not going to get mad at you. I'm not going to say, wow, you don't know how to do math, because this is just a calculator trick. So if you have the calculator at home with you, then you can go ahead and try this. If you're watching this video in class and you have that calculator next to you, then you can go ahead and try this. You're going to do menu, analyze graph, find the 0. You have to do your left bound and your right bound, and then enter. So remember that the 0 of a function is a value of x that makes the output equal 0. So a 0 is also known as an x-intercept. So that is all for today when it comes to graphing functions. We'll do a little bit more of graphing functions in the future just because it is a difficult topic. So these are the notes just for today, and then you do have your assignment that is on Canvas. So thanks for listening.